Oh, there we go. I'm getting, for some reason now we just tilted just right and I can see, no, don't move any more further. And I can see the slide a little better. All right, which is cool. So here, this is under a magnification of 10x, and that's probably what we'll ask you to know it under. So you see a lot of these structures, and again, these open, you see the open, the contrast in staining. All right, all these open areas are filled with the hormone, so they're non-cellular, they're a secretion. The actual hormone is substance of chemical secretion. Whereas here are the cells, and these are basically simple cuboidal cells in this case, that surround this open area, and in this case, and in this case, and in this case. All right? And these simple cuboidal cells are cleverly called follicular cells because this whole structure is a follicle. And follicle is a very generic term. We're going to use it a lot in A&P2, so don't be surprised. Lobules are used a lot, follicles used a lot, nodules used a lot. They are just, there's only so many words we can use to describe some of the structures, and so don't be surprised by that. And I often refer to these as generic words. But a follicle, a nodule, a lobule, that's a whole structure. And structures are always made up of cells. And so here, if you look at a higher magnification, you will see that these nice round nuclei, these are all cuboidal, simple cuboidal cells, which are very good at secretion, as you learned in AP1. So follicles, and this whole makes this whole thyroid, this section from a thyroid gland, look very much like Swiss cheese, all right? Because it's got all this kind of holy appearance to it. There's also some cracks and sometimes and blood vessels. Often this might be the longitudinal sections of blood vessels too, because endocrine glands have a lot of blood in them. All right. Now something else that you see on this is a structure here, which is a lot denser. Right. You can see the contrast between these two things. And let me move the slide just a little bit to get more of that structure there. Yeah. So suddenly now I've got a whole lot of this in the middle, and most of what you're seeing on the screen is this structure with its boundary right about here. This is actually called the parathyroid. It is a separate gland, so separate organal structure. It is encapsulated, there's a thin line to show you this, by some connective tissue. And this is called, again, the parathyroid. So para means next to or neighbor of, and that's what they are. The parathyroid are about 4 to 8 small circular glands that are found in the posterior aspect, so you can't see it on this model, right? They didn't make it. They would be here. You have one model, the brown man torso, which shows some of the parathyroid glands, but they're just tiny, tiny little islands, right, in this sea of follicles and follicular cells. And the parathyroid gland is responsible also for calcium balance or homeostasis in the body. The parathyroid gland is a solution to a problem when calcium's too low. So the neighboring cells that make calcitonin, and those are made by cells outside the follicles, really, if you're not surrounding the space itself, you're a extra follicular cell, and you make calcitonin. And calcitonin, again, remind you, was made when your calcium levels were too high in the body. Well, parathyroid gland makes a hormone, cleverly called parathyroid hormone, which is made and released when calcium levels are too low, right? Because what goes up can go down. So when calcium levels are too low, the answer to that problem is parathyroid hormone. And so blood flowing through, again, the gland would be sensed by the cells. And the cells then would have similar targets to what calcitonin is, but it would do the opposite. So parathyroid hormone will target bone as well, but it's not going to activate osteoblasts, it's going to activate osteoclasts, right, the bone destroyers. And that way the bone starts to be reabsorbed, and calcium, and phosphate by the way too, would be released into the blood. Solution to the problem. The parathyroid hormone would also target the kidneys, right? Kidneys kind of shown on this model here, right? I pointed at myself, kidneys. And it would target the small intestines, which would sit somewhere in this region. There's the duodenum of it. And when it targets the kidneys, of course, this time it's going to tell the kidneys to conserve calcium. Don't pee it away, because our levels were too low. We need to bring them back up. So don't pee it away, right? Keep it. And it would also target the small intestines, right? And tell them, basically, or instruct the cells to absorb more calcium from the diet. So if you were indeed consuming calcium, if it was in your diet, then under the influence of parathyroid hormone, you would absorb it more efficiently, right, in order to keep your calcium levels higher in the body, right? So together, parathyroid hormone and calcitonin made by these extra, right, outside the follicle cells, will help control calcium levels and keep you alive, right, maintaining neuromuscular function.